Some of the questions on the homework you need a calculator for, but quiz tomorrow's no calculator. You can work them all out without a calculator. So starting with number 2, it says consider the following function. Find the equation of a tangent line to the graph of f at a given point. So a tangent line, we want to take the derivative to find the slope. So we're going to take our derivative of our function. So f prime of x is equal to, what's the derivative of x squared plus 3? 2x. Awesome. And then to find what our slope is, we plug in x. So we're finding f prime of 1. So we plug in 1. So this would be 2. So 2 is our slope. The question's asking for an equation. So our equation, we want to use y minus y1 is equal to m times x minus x1. So our point is going to be our x1, y1, and we have the slope, which is 2. So we're going to plug that in. So y minus 4 is equal to 2 times x minus 1. Solve for x, or solve for y. We want to put it into slope-intercept form. So we're going to get our y all by itself. So I want to distribute and add 4 to the other side. So y is equal to 2x minus 2 plus 4. Y is equal to 2x plus 2. So that would be our equation of the tangent line. There's not going to be any graphing, but to find our graph, see which one has the point of 1, 4 and what tangent line has the slope of 2. The only graph that has a point of 1, 4 would be the bottom left one. So it intersects at the point 1, 4 and has a positive slope of 2. So 12 says, determine the point at which the function below has a horizontal tangent line. Well, what's the slope of a horizontal tangent line? 0. So we want to find when our slope of the line that's given is 0. So let's find our derivative. So y prime, what would our derivative be here? Awesome, 18x. So we want to find when 18x equals 0. So x equals, if we divide both sides by 18, x equals 0. So that's the x coordinate. To find the y, we plug it into our original function. So here we have y is equal to 9 times 0 squared plus 3. So y equals 3. So our point would be 0, 3. Next, let's do 13. So a ball is thrown straight from the top of a 460-foot building with the initial velocity of negative 28 feet per second. Use the position function below for free-falling objects. So we have negative 16t squared plus our initial velocity is going to go into the VO. So that would be actually minus here because it's negative. So minus 28t. And then our initial position goes into SO, so that would be plus 460. So this is the formula for our position. If it doesn't give you an initial velocity, you don't plug in anything there, it's just 0. I think the next question is like that. There is one more that we're going to practice like that, where it doesn't give you an initial velocity, so you just don't put anything in there, you just skip. It'd be like if it was 0. All right, so here it asks us for what's the velocity after 2 seconds. To find our velocity, what do we have to do? Find the derivative. Perfect. So the derivative of our position is the velocity. So S prime of t is the same as v of t. The derivative of your position is the velocity. So our velocity would be negative 32t minus 28. So when it says, what's the velocity after 2 seconds, what would we do? Plug in 2 for t. So v of 2 would be negative 32 times 2 minus 28. So that would give us negative 92. Negative 92 feet per second, since we're talking about velocity. For this question, don't worry about the second part. I worked it out in the answers if you want to see it, but I don't really want to waste time doing it. I want to get to the more important stuff. So don't worry about the second part of this question. All right, let's look at 14. So consider the following function. Find the average rate of change for the function below over the interval 5, 5.1. So for the average rate of change, our formula is, here it uses f, so f of t2 minus f of t1 over t2 minus t1. So average rate of change is just your slope formula, the change in y's over the change in x's. So to find f of t2 would be the second number, so 5.1. We've got t1 and t2. So f of 5.1. We're going to plug in 5.1 into our function. So that would be 4 times 5.1 squared minus 5. This one you can use a calculator for. Again, the numbers on the quiz tomorrow work out nicely. So no calculator for the quiz, but I'm okay if you use it for the homework. So 5.1 squared times 4 minus 5. We get 99.04. We also want to find f of t1, which is f of 5. So 4 times 5 squared minus 5 would be 95. So when we plug this into our formula, we have 99.04 minus 95 over 5.1 minus 5. So this would give us 4.04 divided by 0.1, which would be 40.4. 40.4, we're talking about the average rate of change. So this is, it doesn't give us any units here. So no units. Typically it'd be feet per second. It doesn't say here. All right, so we're going to compare this to the average rate of change to the instantaneous rates of change at the endpoints as well. So we're comparing it to kind of like the instantaneous velocity. We want to find the derivative and then plug in the numbers that it gives us. So let's find the derivative f prime of t. What would our derivative of 4t squared minus 5 be? 8t. So f prime of 5, because it says at t equals 5, we're going to plug in 5, would be 8 times 5, which is 40. And f prime of 5.1, so 8 times 5.1 would be 40.8. So if it asks for the average rate of change, you're using their slope formula. If it asks for the instantaneous rate of change or the instantaneous velocity, take the derivative, plug in the number that it gives you. 15. A silver dollar is dropped from the top of a building that is 1,343 feet tall. Use the position function below for free-falling objects. So we have negative 16 t squared. It doesn't give us an initial velocity, so we're just going to cross that out. It's like if it was 0. Plus the initial position, which is where we dropped our ball from, so 1,343. So this is our position function. So if it doesn't give us an initial velocity, just cross it off. We don't put anything there. Determine the position and velocity of the functions for the coin. So here is our position function. This is the answer to A. Just asking for the equation. How would we find the velocity function, v of t? What would we do? Take the derivative. The velocity is the derivative of the position, so we just take the derivative. What would our derivative be? Negative 32t. For B, it says determine the average velocity on the interval from 2 to 3. So average velocity, we're going to use the slope formula, but we plug it into the position function. So we want to find s of 3 minus s of 2 over 3 minus 2. So for this question, use a calculator. That's fine. The numbers are going to be nicer on the quiz. So s of 3, we're going to plug 3 in. So negative 16 times 3 squared plus 1343. So you should get 1199. And then s of 2 would be negative 16 times 2 squared plus 1343. This would be 1279. So when we plug it into our formula, we get 1199 minus 1279 over 3 minus 2. So that would be negative 80 over 1, which would just be negative 80. Negative 80 what? We're talking about feet per second here. If you don't put the unit on a question like this on the quiz, you will lose points. So make sure you put the unit. Any questions here? Bella? So average velocity is the same as the average rate of change. Gives you an interval. You have to use the slope formula. To find an instantaneous velocity, it's just going to give you one number. So you plug that into the derivative. Any questions here? All right, for D, it says find the time required for the coin to reach the ground level. So we want to find when our position is 0. So I'm going to set my position function, s of t would be negative 16t squared plus 1343. We want to find when this equals 0. We're solving for t here. So I'm going to subtract 1343 on both sides. Negative 16t squared equals negative 1343. Divide by negative 16. We can put that in our calculator. We get 83.9375, and then take the square root. So 9.162 here. So this would be when our coin hits the ground, when your position is 0. For E, it says find the velocity of the coin at impact. So velocity, we're using our derivative, so that would be v of t. But what are we going to plug in t here? When is impact? When it hits the ground, which is what we just found. So v of 9.16. I think WebAssign wants the whole decimal that we plug in, so it was 9.16174. I'll leave it here. And then let's plug this in. So this is equal to, our velocity was negative 32 times t, which we're plugging in 9.16174. So I'm going to multiply my answer by negative 32. So you should get negative 293.176 feet per second. We want to use the product rule to differentiate the function, so to find our derivative. So the product rule is the first times the derivative of the second plus the second times the derivative of the first. So our first would be 3x plus 8. What's the derivative of x cubed minus 4? (3x squared), perfect, plus the second, which is x cubed minus 4, times the derivative of the first. What's the derivative of 3x plus 8? Three. Awesome. So then let's simplify. I need to distribute here. So 9x cubed plus 24x squared plus, we're going to distribute here, so 3x cubed minus 12. Combine our like terms. So 12x cubed plus 24x squared minus 12. So this would be our derivative. So if you're multiplying two functions together, use the product rule. You could also FOIL from the beginning and then find the derivative after you FOIL. You'll end up with the same answer. I'm okay with you doing it either way, whatever it takes to get the right answer. All right, 17, we want to find the derivative of the function. So here we're dividing, so we want to use our quotient rule. So low d high minus high d low over low squared. Yes. It'll just say find the derivative. But you can tell by the way it looks, if you're dividing like a function like 17, you're going to have to do the quotient rule. Like 17, there's no other way of getting around it. If you had something like 1 over x squared, or let's say 10 over x squared, you could do the quotient rule here, but it would be easier to change it to 10x to the power of negative 2 and then find the derivative that way. So you have the freedom to find the derivative however you want, but for a question like 17, you have to use the quotient rule. So low would be x squared minus 5 times the derivative of what's up top. What's the derivative of 3 minus 2x minus x squared? It'd be negative 2 because the x would go away, minus 2. Oh, yeah, you just had it backwards. Yeah, you were right. Negative 2 minus 2x. Minus, what's up high? So 3 minus 2x minus x squared times the derivative of what's down low. What's the derivative of x squared minus 5? 2x over low squared. So x squared minus 5 squared. So now we want to simplify. The other class asked, is it possible to cancel out the x squared minus 5s because I have one in the top and the bottom. But I don't have one in both terms on top, so you can't just cancel. In this step, nothing's going to cancel out. You're going to have to FOIL or distribute to simplify. So you can't just cancel them out. So in our first two up here, we want to FOIL. So we got negative 2x squared minus 2x cubed plus 10 plus 10x. And then here I'm going to distribute. I also need to distribute the negative. I'm going to do two steps in one here, but be careful. This is one of the most common mistakes that people make with this question, is that they won't distribute the negative or they'll distribute wrong. So be careful with distributing. We get negative 6x plus 4x squared plus 2x cubed. I'm going to combine my like terms next. So starting with my x cubes, those cancel. And then x squareds, we get 2x squared. And our x's would be plus 4x plus 10 over x squared minus 5 squared. So this would be our derivative. You don't have to expand the bottom. You could if you want, but don't waste your time doing it. Just leave it as your binomial squared. Any questions here? So for 18, in the answer key, I think I worked it out two different ways. You can use your product rule since you're multiplying these two together, or you could combine them from the start. So I think I did it both ways. You can multiply the x to the 5th power to both. So x to the 5th power minus x to the 5th power over x plus 5. So in the answer key, I distributed, and then I found the derivative of each of these. So I found the derivative of x to the 5th power, which was 5x to the 4th power. Minus, here I had to do the quotient rule. So I found the derivative of that, and then I just left my answer like that. Or what we could do is combine these together. So I could find a common denominator here, combine them together to be one fraction. So we had x to the 5th power times x plus 5 minus x to the 5th power over x plus 5. So when you combine it, you get this. You can simplify it a little bit more and then use your quotient rule from here. Either way works. Your answers will look different. Either way you leave it. Yeah, that's fine. Yeah, for the answer key, I did it both ways and worked them out. I think both ways that I did it, my answer didn't look like the one from WebAssign here. I had it that was distributed, so it was like 5x to the 6th power. But depending on how you start it, your answer might look a little different. Yeah, you would do low D high to this one. Low D high minus high D low over low squared to this. All right, let's look at 19. Find an equation of the tangent line to the graph at the given point. So to find the equation of a tangent line, what do we have to do? This was like number 1 and 2 that we did from the review. Take the derivative. So we're finding the derivative of our function here. So since we're dividing, we have to use our quotient rule. So low D high minus high D low over low squared. The derivative of a constant number is 0. So x squared plus 4 times 0 minus high, which is 8, times the derivative of our denominator. So what's the derivative of x squared plus 4? 2x. So x squared plus 4 times 0 would just be 0. That would go away. So we get negative 16x on top over low squared, which is x squared plus 4 squared. Now this is our derivative. This is f prime of x. It's asking us for the tangent line. So to find the slope, we take the derivative and we need to plug in x. So we want to find f prime of 2. So negative 16 times 2 over 2 squared plus 4 squared. We get negative 32 over 2 squared would be 4, plus 4 is 8, squared would be 64. This simplifies to negative 1/2. So negative 1/2 is our slope. So we found the slope of our tangent line. How do we find the equation of the tangent line? We're going to plug it. We want to plug in 2 and 1 and our slope into the equation of a line. So y minus y1 is equal to m times x minus x1. So y minus 1 is equal to negative 1/2 times x minus 2. Distribute. Let's put this into slope-intercept form. Question on the quiz will be specific on what form it wants, which will most likely be slope-intercept form. Negative 1/2 times negative 2 would be positive 1. And then I need to add 1 to both sides. So y equals negative 1/2 x plus 2. So this would be our equation of the line. What if this question said, find the equation of a tangent line to the graph when x equals 2? What if it didn't give me a y? I could still find the slope just like how we did. We would just plug in 2. But when it comes to my equation of a line, I don't have anything to plug into y1. How would I find what I plug into y1? What would we need to do? How do we find our y? If it gives us an x, how do we find the y? If this was like an algebra 2 question. Plug it in. Plug in 2 into our function here. Find the y. So make sure you know, remember this for the quiz. So if it only gave us 2, we'd plug it in. We have 8 over 2 squared would be 4, plus 4 be 8 over 8, which would be 1. So our y would be 1. So that would be our point. So it is possible that the question on the quiz may only give you the x. Plug it into your original function to find the y. Right, next, let's do 20. It says find the second derivative of the function. So we just have to take the derivative twice. First, let's find our first derivative. So our first derivative would be 4x cubed plus 18x squared minus 14x minus 10. Then we take our answer and take the derivative again. So our second derivative would be 12x squared plus 36x minus 14. This is the velocity of an object in meters per second is 35 minus t squared from 0 to 6. Find the velocity v of 4 and the acceleration a of 4 of the object when t equals 4. So to find the velocity, we're just going to plug 4 in. It gives us our function for v. So v of 4, we just need to plug it in. So 35 minus 4 squared would be 35 minus 16, which would be 19. Now for the acceleration, how do we find the acceleration? Take the derivative twice, but here it gives us the velocity, so it's just the derivative once. So it goes position, velocity, acceleration. Position's what you start with. Take the derivative of the position to find the velocity. Take the derivative of the velocity to find the acceleration. So for our acceleration, we need to, I'll find a of t first. We need to take the derivative of our velocity. So that would be negative 2t. So a of 4 would be negative 2 times 4, which is 8. Negative 8, yes. A of t is the derivative of v of t, yes. So an automobile's velocity starting from rest is given by the equation below, where v is measured in feet per second. Round your answer to 3 decimal places. So it gives us the velocity, but it wants us to find the acceleration at 5 seconds. How do we find our formula for acceleration? Take the derivative. So we have to take the derivative of this. So v prime of t is the acceleration. So let's find our derivative. We're dividing here, so we have to use our quotient property. So low d high minus high d low over low squared. So 5t plus 16 times the derivative of the numerator, so 115 minus 115t, times the derivative of our denominator, which would be 5, over low squared. So 5t plus 16 squared. You can simplify, or if you want to, it's asking for the acceleration at 5 seconds, so just plug in 5 into this, but I would simplify first. Again, your numbers are going to be nicer on the quiz. So we have 115 times 5t would be 575t plus 115 times 16, 1,840 minus 115t times 5 would be 575t. These cancel. That's nice. So we get 1,840 over 5t plus 16 squared. So now to find the acceleration at 5 seconds, we're going to plug in 5. So 1840 over 5 times 5 plus 16. So from here, I'm just going to plug it into my calculator. So 25 times 16 would be 400 squared. (25 plus 16 would be 41. And 41 squared would be 1681. So then 1840 divided by 1681 would be 1.095. Acceleration, our unit, it's the same as velocity, but instead of feet per second, it'd be feet per second squared. For B, you're doing the same thing, but you'd plug in 10 into your acceleration formula. And then for C, you're doing the same thing, but you plug in 20. So super, super, super important. The position, S of t, is the velocity. The derivative of the position is the velocity. So S prime of t is velocity. And then the second derivative of our position is the acceleration.